Good morning. My name is Benedita and it is a pleasure to be here at WorldCIST 2021. I'm presenting a joint work with Fátima Leal, Bruno Veloso and Juan Burguillo focused on crowdsourced data stream mining for tourism recommendation. The presentation will cover four main topics. So I'll go through the research problem, talk about data stream mining for recommendation and its subtasks, and then focus on research challenges and trends. The research problem we address in this work is the identification of the research challenges and trends regarding data stream mining for recommendation. In this context, which is the context of platforms such as TripAdvisor, Airbnb or Expedia, the tourists are provided with a set of personalized recommendations, which they will then provide feedback on, and that feedback can take the form of ratings, textual reviews, likes or dislikes, and the system will build and maintain updated profiles of all contributors, all of those tourists who have shared their feedback, and with that information, personalized recommendations will then be issued for the current users of the platform. In the last task involved in this type of platforms is the evaluation, which compares the actual feedback from the tourists with the suggested recommendations. This is a harder problem than standard recommendation, since standard recommendation is by default performed offline. This is online data stream recommendation. So data stream profiling can use all information available to generate the profiles of the contributors, those who provide feedback. And so it is possible to have rating-based profiles, review-based profiles, which is based on textual reviews or messages, context-based profiles, which use context-aware information such as location, time, etc., to build profiles. And then there is also quality and popularity profiles, trust and reputation, which model the reliability of the contributors, of the data contributors. And all these different types of profiles can be built and used together, giving rise to hybrid profiles. Main task is, of course, recommendation, which can be divided into three subtasks: pre-filtering, recommendation, and post-filtering. Pre-filtering is usually applied to select a subset of data as input. This is the case of context-aware pre-filters, which filter all data based on the current location of the user or at the current time of the system. And so these pre-filters can be used to reduce the size of the input data. The recommendation filters themselves, typically they can be content-based or collaborative filters, or combinations of both. The combinations tend to minimize their weaknesses and potentialize their strengths. So content-based recommendation is based on the features of the users and of the items, and the items are suggested based on the similarity between the profiles of the item and user. Collaborative filters. They are based on like-minded users. Usually they can be classified into memory and modal-based recommendation filters. And so these two types of filters will provide a list of recommendations to the active users. These recommendations can be further tailored by post-filtering, and the post-filters usually reorder the recommendations generated by the recommendation stage, or even remove some items. The last task involved in this data stream recommendation process is the evaluation, and the evaluation in this context usually adopts the sequential evaluation protocol with sliding windows, and these sliding windows can take into consideration the space, the learning time, or the accuracy, together with the standard predictive classification or statistical metrics. But these metrics, although they are similar to the offline counterparts, they always need to be adapted to the data stream scenario. Considering technologies, the two most promising technologies found, they include blockchain, as well as high-performance computing or cloud computing infrastructures. The HPC is particularly well suited to this type of systems, since it allows the processing of big data, and blockchain can be used as a platform, a means to maintain and trace back all feedback which has been provided so far. Considering the challenges involved in this type of platforms, we have identified the following. So concept drifts occur in data stream environments, but not in offline environments. And they represent evolutions in the data stream which are not compliant with the previous behavior of the data stream. So, in fact, they can be used as a means to detect when to perform modal learning, because they are just indicated that the model is no longer adequate to the current input data. So this leads to modal learning, and modal learning must be included in or contemplated in these scenarios. Otherwise, the system will no longer provide relevant recommendations to the active users. Another issue has to do with the natural preference evolution of users. And so techniques such as forgetting techniques are essential to maintain the focus on the current interests of the users. Algorithmic transparency is also a must, since it boosts the confidence of the user in the system, and in this context it means explaining the rationale behind the recommendations given to the users. So the identified data stream recommendation research trends are related with the challenges, and they include the reliable profiling of contributors, because by default the contributions are unfiltered. The concept drift detection, because it is a means to identify when to trigger modal learning, and this can be done by monitoring relevant metrics. The dynamic modal learning, which will allow the system to continue to generate meaningful recommendations as time passes. Include mechanisms to, or develop mechanisms to model the user preference evolution, and thus ignore outdated preferences. Algorithmic transparency, in this case the explanation of recommendations to boost the confidence in the suggestions. The adoption of blockchain as a technology which will grant data integrity, history and traceability, and also HPC to support the processing of big data in real time, which in this context is the profiling, recommendation and evaluation of the crowdsourced data. So as conclusions, we have reviewed crowdsourced data stream recommendation platforms, considering the main tasks, which are profiling, recommendation and evaluation, together with the support technologies. Based on this review, we have identified current research challenges and trends. Already based on this work, we've been working recently on transparent recommendations by means of explanations, and are also starting to classify crowd contributors. And this classification is binary, since we intend to identify benevolent users as opposed to malevolent users. So I would like to thank your attention, and I will be glad to answer any questions you may have. Thank you.